Welcome back to another video on linear relations. This one solving a system of equations using something called the elimination method, and a little shout out to the substitution method in this video as well. Let's have a look. Okay, so now that we know that a solution to a system of equations is one specific ordered pair that satisfies two different equations, let's look at some other ways we could find the solution to a system if we're given two equations. Now you have to remember we can always find the solution to a system of equations using that comparison method that we've already learned. So if you're more comfortable with that, you can stick with comparison method, convert your equations to y equals ax plus b, and solve that way. But if you're looking for something new or you're feeling a little bit brave, let's have a look at elimination method right now. And this method of solving a system of equations is pretty straightforward, although it's different from what we're used to. This method is used when we have two equations given to us in a question that look like this. So you're wondering, when are we going to get to equations that look like this? Well, it's usually in a word problem, and if we're lucky, they're going to make it really obvious for us by putting the information in that word problem in a table that looks just like this. And if it's not given in a table, then we might have to find the equations in the sentences of a word problem, kind of like this. In either case, it's important that you know where the x and the y variables come from. Notice in the question that the numbers I'm given represent quantities. They represent a number of something that I don't know the weight of. Notice how that at no point in this question am I given the weight of a silver bar, so I'm going to represent it with the variable x. Now beside the second number in each equation, I'm going to represent the unknown weight of a gold bar with the variable y. Now notice when I add up my terms, when I add up the number of silver bars and the number of gold bars times the weight of each bar separately, I get the total weight of each shipment. So I'm going to put my equal sign right before the total weight in each equation. So now that you see where we get these equations from, let's solve this system. Now the first thing you have to notice that's really important here is that my like terms are all lined up over each other in the two equations. I stack these equations nicely lined up, one over the other. Now I'm going to start out by multiplying each equation, each entire equation, by the number that's in front of the x variable from the other equation. So notice on the top equation I have a 10 in front of x, and on the bottom equation I have a 5 in front of the x. Well, since that 10 is in front of x in the top equation, I'm going to multiply the entire bottom equation, each term in it, by 10. And I'll multiply the entire top equation by 5. So each term gets multiplied one at a time by those numbers. Now after my multiplication, notice what happened to those terms in front of x. The whole point of doing this was to get those numbers the exact same in both equations. I want the numbers that are in front of x to be identical, and they are. Now this is important because this is where the word elimination comes in. I'm going to subtract each term in the bottom equation from the corresponding term in the top equation. And what this is going to do is get rid of that term with x in it completely. Look what happens. Now don't forget here, when you subtract, each term in the bottom equation needs to be subtracted from the term that's above it in the top equation. Now all that I'm left with here is a term with y in it and a number on the other side of the equal sign. So now I'm going to go ahead and divide by what's in front of the y variable on both sides of equals. This is isolating the y variable, and voila, that is the solution to the y value in this system of equations. Now all I need to do is take that y value, plug it in, and solve for x to get the corresponding x value in this solution. So that's how I use the elimination method to solve a system of equations. Now that I've done that, I'm going to run through those steps for you so you can do it again on your own. Before I do this, remember, you can ask yourself, if I'm more comfortable using the comparison method, you can always do that. This is just a method that if you want a different way of doing it, you could follow. So here are those steps in the elimination method. First, line up your equations nicely, one over the other, with the corresponding terms right above each other. Second, multiply each equation by the number that's in front of the x from the other equation. Third step, subtract each term in the bottom equation from the corresponding term in the equation above it. This is going to eliminate the x variable altogether. Fourth step, you're going to solve for y and then take that value and plug it back into the equations to solve for the x value. And that's how you use the elimination method. Now here I'm going to mention something called the substitution method that you might have heard of. This method, substitution, is used when we know the value of one of the variables. So let's say I have an equation like y equals 3x minus 8 and another equation that simply says x equals 6. Well, the substitution method says that since I know the value for x, I can substitute it into that first equation and solve for y. It's also a little bit of common sense. If you know what x is, just go ahead and plug it in or substitute it into the other equation. So I'll do that here just to show you what it looks like, and you'll see that I know the x value is 6, and I can find the y value really easily to get the solution to this system of equations. Now this would also work if I was given a value for y. Let's say I had an equation y equals 10x minus 8, and I know that y is equal to 4. Well, I could plug 4 in for y and solve that x value pretty easily, and that would be the solution to the system, that x with the y that I was given. So that's it for the elimination and substitution methods. Let's watch a couple more examples to make sure we get it.